Yeah, good evening. Yesterday you have seen arrays. Yesterday you have seen arrays. What is array? Collection of similar data elements, same type of elements, nothing but homogeneous elements. Okay, same type of elements or similar data elements or homogeneous element is all same. Now array index starts from 0, ends with -1, size -1, size -1. Array index starts from 0, ends with size -1. Okay. Now array itself in Java language, array itself object, array itself object. Array reference we can also call it as object reference. We can also call reference variable. What is the difference between primitive type variable and reference type variable? Primitive type variable contains data. Reference type variable contains hash code. That is, remember, any reference, that is hash code. Any primitive, data. Okay. Arrays also, strings also, classes, interfaces, these all reference type and contains hash code. Okay. Primitive type data. You have seen arrays yesterday. See, integer array operator A equal to new integer of 10. If I write like this, okay, if I write like this, new is a dynamic memory allocation operator. It allocates a memory for 10 integers. New is a dynamic memory allocation operator. It allocates a memory for 10 integers. This is right side array created. This array itself object. This object referred by A. This object referred by A. A contains hash code. Okay. This A we can the light is there blinking. Still it is blinking. Just call admin. Call admin. Just call admin. Admin or office boy is there. Just wait, online students, wait. Just wait. See, here, right side array created. See, right side array created. Right side array created. Okay. This array referred by A. So, new is a dynamic memory allocation operator. It allocates a memory for 10 integers. After that, that hash code stored in A. That hash code stored in A. This is object. This is object reference. Otherwise, this is array. This is array reference. Okay. You can call it as reference variable. Okay. Reference variable. This array operator we can write here also. Okay. This array operator here also we can write. Okay. This array operator here also we can write. Okay. So array operator after array reference also we can write. Before array reference we can write. After data type also we can write. But in 3 ways, this is recommended, best one. Because suppose if you write like this, now A is a primitive or reference. If I ask, you'll observe only this one, you may think like a primitive. That's what, if you write like this, now is it primitive or reference? If I ask, you'll observe array operator also. That is the reason it is recommended. Okay. Now, is it primitive type variable or reference type variable? Reference type variable. Okay. Now, this is declaration. Declaration time, you can write size. But initialization time, you should not write size. Error comes. Declaration time, you can declare with size. But initialization time, suppose if you want to initialize, like this you have to write. So you can write n number of elements, automatically it will take size like this. But here size you should not write. Even this is also not required. It is also valid. It is also valid. Okay. So if you write like this, right side array created. Right side array created. So array is right side. Array is right side. Don't think this is array. That is array reference. Okay. After creating array, how to print elements you have seen. With enhanced for loop also possible. Normal for loop also possible. Okay. Now, if you want to go for enhanced for loop, for after that data type, one variable colon A. If you write like this, one element copied in B, that B you can print. System.out.println B. Like this. Suppose this is only printing as seen yesterday only you have seen. Now, if you want to perform some other task, for example, in this 5, which is a maximum? In this 5, which is a minimum? Which is second largest? Which is second smallest? Or sorting, searching for one element? This type of operations. Many things possible. But in Java, no need to write that type of logics. We have a library. Separate array class is there. With that class contains methods. So sort method is there. Just if you call method, it will be sorted. If you call search method, it will be searching also finished. So like a C language, no need to write logics. We have inbuilt methods. Predefined methods are there. With the predefined methods, actually this loop also not required. We can print with predefined methods. So without loop also printing possible. That type, so many methods are there. You will study further sessions. Like one arrays class is there. That is today you cannot understand because so many concepts required to understand. There is one Java P command will be there. You will study further this one. Java.util.arrays. One class is there. If you enter these many operations we can perform on arrays. See how many methods are there? Hundreds of methods are there. These many. These all we can perform. Now without writing logic, we can perform. That is the reason sorting, searching, hashing and finding maximum, finding minimum, second largest, second smallest, these all not required. With library we use. Okay. Like practicing purpose you can do. That is I'll give assignment. Assignment I'll give. Assignment I'll explain. So I given time up to Friday. Okay. Just tomorrow. Tomorrow is Thursday. Today is Wednesday, no? Wednesday, Thursday, Friday. Just 1-2 days. You try to complete. Friday, I'll explain. I'll discuss. Okay. Now, if you want to calculate sum here, suppose, very simple. Just here integer total. Here total equal to 0. See, total equal to total plus b. One element added to total. But these all no need to do. We have a library. That is, we'll see later. Just one more example. This is after completion total. So first what will happen? From this A, nothing but array. First element 13. 13 copied in B. 13 added to total. Total 13. 13 again 34 copied in B. 13 plus 34 result stored in total. Again 45 that is copied and 32 added. 13 added. After terminating for loop, the total printed. See, file, save. If I compile java c demo.java, java demo 137. Okay, write this one example also. So one element added to total, at last total printed. All other operations by using libraries we'll see later. Here no condition, nothing. It is automatically one element copied in B. Because this is not a normal for loop. This for loop is called enhanced for loop. We can also call for each loop. Enhanced for loop or for each loop. This loop introduced in 1.5 version. Previously it was not there. Later came. Okay. So it is syntax for data type, variable, colon, array reference. That's it. Is it over? You studied class. What is class? Collection of variables and methods. Variables related concepts over. Okay. Now methods. Now methods. Which one? Yeah. See, class is a collection of variables and methods. Variables part is completed. Now methods. Next, note down. Methods. Which one? I didn't get you. Arrays class you are asking, but immediately not possible. Because these methods, if you want to access arrays class, library required. Object-oriented programming knowledge required. I'll teach. Order different. Okay. Now, next methods. Note down. A group of statements into a single logical unit is called as method. A group of statements into a single logical unit is called as method. A group of statements into a single logical unit is called as method. A group of statements into a single logical unit is called as method. Say, statements if you group together as a one unit, that unit is called method. It is nothing but C++ programming language functions. Java methods. Okay. Inside the class if you write method, outside the class if you write function. Now A group of statements into a single logical unit is called as method. In Java, methods are divided into 4 categories. First one, methods with arguments and with return value. Second one, methods with arguments and without return value. Third one, methods without arguments and with return value. Fourth one, methods without arguments and without return value. Methods with arguments and with return value, with arguments and without return value, without arguments and with return value, without arguments and without return value. 4 combinations of methods. If you want to perform any task, the task code we have to write inside the method. So methods are used to perform the task. Methods are used to perform the task. Advantages of methods. First one, modularity. Second one, reusability. First one, modularity. Second one, reusability. I'll teach. In the example, I'll teach. Now one category we'll see at the time. First category time only, I'll explain what is modularity, what is reusability. I'll show you. First category, methods with arguments and with return value. Syntax. Syntax, return type, method name, argument 1, argument 2, like this n number of arguments, statements, methods with arguments and with return value. Methods with arguments and with return value. Syntax. Here, return type can be primitive type or reference type. Primitive data type or reference data type. Primitive data type or reference data type. These arguments also primitive types or reference types. Methods with arguments and with return value. Methods with arguments and with return value. Based on your task related word, we have to write as method name. For the task, whatever you record, those all you have to write arguments. At last result, whichever type comes, that type you have to write return type. This is first category. Here we have to write task code. Here we have to write task code. See, methods are used to perform the task. Methods are used to perform the task. For any task, the task related word you have to write as method name. After that, what are the arguments required for the task? You have to write. At last result, whichever type comes, that type you have to specify. That is method. Now, if you see example, you'll get a more clarity. Okay. Here, return type can be primitive data type or reference data type. Here, arguments also can be primitive types or reference types. Depends upon our task. Okay. You already studied data types, primitive data types, reference data types. How many primitive data types are there? 8. What are those? Byte, short, int, long, float, double, char, boolean. 8 data types. What are reference data types? Arrays, strings, classes, interfaces, dash dash, many. Okay. Enumerations also further many comes. So don't forget, remember. Okay. Now here, according to our task, if primitive required, primitive you have to select. Reference required, reference you have to select. And after that, result whichever type comes, that type you have to mention. Now you see, for example, just re-login if screen is not visible. Only one person means problem your side. See here. Without class, we cannot develop applications. So class name, open brace, close brace. Without main method, we cannot execute program under operating system. That's what main method, open brace, close brace. Till I didn't explain this line, not completed, but just a class concept is studied. Class name is studied. This line not completed. You are learning methods. After completion of all methods, main method you'll understand. Okay. Now here I am writing another method. Now I want to add 2 numbers. Method name add. I want to add 2 integers only. So integer A, integer B, arguments. Here after adding, result also integer. That's what integer return type. Now here I'll add integer C equal to A plus B. Return C. You studied statements, selection statements, iteration statement, jump statements. In a jump statements, return statement, last statement. Okay. This is the return statement. In a jump statement, 5 statements are given. Break label, continue label. It is written. It is also, it will jump because add method to main method, it will jump. That is the reason it is called jump statement. Okay. Like break terminates the loop. Control will jump. No, that's what jump statement. Continue also will jump. Here return also will jump. From here to here it comes. That is, I'll show you with a diagram. Now add is a method which will take 2 integers, and after adding result also integer, that is return. That return type integer. Now you studied already integer x equal to 10 if I write. That is instance variable or class variable or local variable. Instance variable. Okay. How many ways to access this instance variable? 2 ways. What are those? By using object reference. Okay. Same. Now if I write static, which variable? Class variable. How many ways to access? 4 ways. What are those? Directly, class name, object reference. Okay. Same style. This is called instance method. If I write one static keyword here, it is called class method. Okay. Class method we'll see later. First instance method. Now before going to that one, note down instance method. A method that is defined as a member of a class. is called as an instance method. A method that is defined as a member of a class is called as an instance method. A method that is defined as a member of a class is called as an instance method. A method that is defined as a member of a class is called as an instance method. See, a variable that is defined as a member of a class, that is called instance variable. A method that is defined as a member of a class, that is called instance method. See, static variable we are calling like a class variable. But why we are calling non-static variable as a instance variable, static variable as a class variable is, instance variable also we are writing inside the class only. Class variable also we are writing inside the class only. But instance variable, instance compulsory, no? That is the reason instance variable. Class key, class variable with class name will access, no? That's what class variable. Like that. Both are will write in a class only. Okay. Now, the two instance variable specific to instance. If I create 100 objects, 100 copies created, every object separate. Class variable 1. That is not irrespective number of objects. Like one class related. That's what class variable. But both will write in a class only. Okay. Now, a method that is defined as a member of a class is called as an instance method. Next, write it. There are two ways to access an instance method. Same concept. First one, by using an object. Second one, by using an object reference. Use object to access an instance method if it is required only one time. Use object reference to access an instance method if it is required more than one time. Use object to access an instance method if it is required only one time. Use object reference to access an instance method if it is required more than one time. Use object to access an instance method if it is required only one time. Use object reference to access an instance method if it is required more than one time. Same. Whatever you studied about instance variable, like that only. Is it over? So if you define method as a member of a class, that is called instance method. Further, two ways to access: with object reference. One time required, go for object. More than one time required, go for object reference. Okay, like that you have to select. Now I'll show you both. Is it over? Now see, it is instance method. I want to access here. Now, here return type integer is there. So you have to write something integer x. Okay. It is instance method. For calling this method, either object or object reference compulsory. Suppose object I'll write new constructor. if I write new constructor, if I write object only, no. Okay, new constructor if I write. Now new constructor if I write object created, no. With that dot add two variables, it will take two values I passed it. So here int is there, int x, add instance method, either object or object reference required. So new demo object created. With that object I am calling add. It will take two variables. So two values integer type I passed it. Now what will happen is object created, with that object add method called, these two values are copied in A and B, result copied in C. The C returned and stored in X. So when this line is executed, first right side executed always. Anything right side only executed. Right side executed and it is passed to here. And result copied in C, return C. The C value copied in X. Here system dot out dot println X. Like this. With object reference if you want to call, demo D equal to new demo. Okay. After this, into Y equal to D dot add. Now two numbers I am passing. System dot out dot println D Y. Now you observe here. First demo class loaded, open brace executed. You already studied execution priority. What is execution priority? Class variables, static blocks, main method. Is there any class variable? No. Next, static blocks. No static block. Next, main method. So this method not called. This method called first. Okay. Demo class loaded, open brace executed. Okay. Demo class loaded, open brace executed. After that, main method called. Open brace executed. Here new demo dot add. Now these two values copied in A and B. So control comes like this. Then what will happen here? Int A equal to 34. Int B equal to 23. Like this. This 34 copied in A, 23 copied in B. 34 copied in A, 23 copied in B. With arguments. Okay. Now with return value, this is copied in X. Then what will happen here? Int X equal to C. Like this. So this is the reason this category name is with arguments, with return value. Okay. Now object created, with that object add method called. Then control comes to add method. This 34 copied in A, 23 copied in B, result copied in C, return. Return value copied in X, X printed. Here what will happen is another object created, that object referred by D, with the D add method called. Then what will happen? 83 copied in A, 42 copied in B, that result copied in C, C copied return and Y printed. Now here addition of two numbers logic I written only one time. I called two times. That is called, this code is reusable. Now 2 lines code is reusable. Later 100 lines code also reusable. 100 lines code you can write. That is n number of times you can call. That is reusability. Okay. Task divided into two modules. Like this is one method, this is one method. Further what will happen? One task divided into number of packages. Each package divided into number of classes. Each class divided into number of methods while developing projects. That is called modularity. Module wise will separate. Always will divide. Then that code will be reusable. Again and again, repeatedly n number of times you can access. That is the benefit. So write this one. So 34 copied in A, 23 copied in B, result copied in C, that C copied in X. Later 83 copied in A, 42 copied in B, again result copied in C, C copied in Y. Like that works. With arguments with return value. With arguments and with return value. Is it over? Method calling is important. This definition I'll give. This one, how to call, you have to give the answer. Okay. See, first of all, how many categories of methods are there? How many categories of methods are there? 4 categories. What is the first category? Methods with arguments and with return value. So, with arguments with return value. Like this will be there. What is second category? Methods with arguments without return value. So with arguments, but no return value. Okay. What is third category? Without arguments with return value. Only return value will be there. That is third. Okay. What is fourth? Without argument, without return value. So sending and receiving is there. We have to use first category. Only sending is there, second category. Only receiving is there, third category. No sending, no receiving, fourth category. Like that, 4 categories. So further, sending will be there, receiving will be there. Sometimes. Sometimes only sending will be there. Sometimes only receiving will be there. Sometimes no sending, no receiving. Depends upon situation, we have to select. Now you are learning first category. So first category like this. Okay. Now this method only, I'll write another method. Now give me answer. Suppose method name cube, which will take one argument. Okay. Which will take one argument. Here, after calculating cube, result also int. Here, integer b equal to a into a into a. Cube calculated. Return b. Now, cube is a method which takes one integer, which returns one integer. Now, this method I want to call by using object. How to call? Give me answer. One int x equal to next new demo dot cube one variable, one value. Next system dot out dot println x. This is with object. With object reference I want to call. Demo d equal to new demo. Next int y equal to d dot cube of one value. Next system dot out dot println y. That's it. Okay. So here object created. This type of object is called. This type of object is called anonymous object. We can also call unreferenced object. Okay. Object created. That object not referred by reference. That's what unreferenced object. Another terminology, anonymous object. So object created, with that object cube method called. Then 5 copied in A. 5 into 5 into 5, 125 copied in B. Return B, the value copied in X, printed. Another object created, that object referred by D with the D cube method called 6 copied in A. 6 into 6 into 6, 216, 216 copied in B. That is stored in B. Return, stored in B, written and stored in Y. Y printed. See, file, save. Compilation, execution. So 5 cube 125, 6 cube 216. Write this one. Is it over? Now, in this program only, I'll teach methods, method components. Method components I'll teach. Say, what is cube here? Method name. What is int A? Arguments. So, suppose only method name and argument. This one, we can call it as method signature. Method signature. Okay. This return type and method name is called as method declarator. Method declarator. Open brace to close brace is called as method body. Method body. Okay. Method declarator and method body. This totally called as method definition. Method definition. This written keyword line is called as return statement. It is called as return statement. Okay. This line and this line, we are calling like a method call statements. This line and this line, we are calling like a method call statements. Method call statements. Okay. What are the arguments you are passing in method call statement? This is and this is actual argument. Actual arguments. Actual arguments. Whatever you are writing here, this is called formal argument. Formal argument. That is terminology you have to remember. Parameter or arguments, both are same, no change. So you can call it as actual arguments or actual parameters. Either formal argument or formal parameter. Okay. Each and every point you have to remember. Each and every point you have to remember. Terminology required. Terminology required to learn method overloading, method overloading time required. While learning polymorphism, while learning inheritance, at the time required. Okay, I'll share in Google Classroom. I'll share in Google Classroom. Arguments, parameters, both are same, no change. But actual formal difference is there. But arguments, parameters, no change. Actual arguments or actual parameters, like that you can call. Formal arguments, formal parameters, you can call. Arguments, parameters, just synonyms. Okay. Is it over? Shall I ask some questions? Give me an answer. Method name and arguments is called method name and arguments. Method signature, return type and method signature. Method declarator. Declaration means semicolon. That is further it comes. Declarator. Okay, declarator. Now, open brace to close brace. Method body. Method declarator and method body. Method definition. Method definition. For calling method definition statements I am writing. Those statements are called method call statements. What are the arguments I am passing in method call statements are called actual arguments. Can I call actual parameters? Yes. What are the arguments we are defining in method definition? Formal arguments. Can I call formal parameters? Yes. Written keyword line. Return statement. Okay. These method components, remember, for learning principles it is required. While learning polymorphism, while learning inheritance, at the time this knowledge is required. Don't forget. Okay. Now one more method I'll give. Give me answers. How to call the method? You have to give the answer. Suppose max is a method. Okay. Which will find the maximum of two numbers. Now, here, return type integer. Here, if A greater than B, return A. Else, return B. Now, I want to call this method. Give me answer. Int x equal to new demo dot match two values. Next, with object reference, demo d equal to new demo int y equal to d dot max two values. Next, system dot out dot println y. Okay. Now, this type of definitions, if I give this type of statements, can you give answer or not? That knowledge is required. Okay. Write this one. After 1 week only, you will not give. I'll show you. After 1 week only. Now it is first category, only one category. All are giving answer. Second category, third category, fourth category, upcasting, downcasting, all comes no over. Confusion started. The only one category, 3 examples over, all are giving. After learning all categories also, you have to give answer. Okay. Now all primitive type, again reference type comes. Reference type also. Arrays will be there, strings will be there, classes will be there, interfaces will be there. What you are discussing? Continuously discussions are happening. While writing notes also discussion, while teaching also discussion, while asking question also discussions. In a classroom, you have to listen. After class, what you understood, what your friend understood, you have to discuss outside the class. But in a classroom only, if you discuss, later what you will discuss? Nothing. You are not listening, your friend is not listening. Then what will discuss later? No use. Okay. Both people listen. You also listen, your friend will listen. What you understood, what your friend understood, outside the class you can discuss. With the discussion, you will get a more knowledge. I'll accept. But in a classroom, no use. Classroom only if you discuss, wasted. Okay. See, again, they are not listening. For you only I said. Now, listen. Is it over? Now, these are all primitive type. Now, reference type. Okay. Reference type arrays only you studied. Suppose method name add elements. Okay. Already you know method second word onwards first letter capital. That's the reason E capital written. Okay. Add elements integer array operator A. After adding elements, result will be normal integer. Okay. Now here integer total equal to 0 for integer B colon A. Just now today only you have seen how to add. Okay. Total equal to total plus B. After this, return total. Okay. Now this method I want to call with object reference. With object reference. What we have tried. Demo D equal to new demo. After this, int x equal to D dot add elements. Now next, here what it takes? Array. Either array you have to initialize or directly also you can pass. Directly if you want to pass, what we have tried. Here you can pass array also. Otherwise you can initialize here integer some array. Okay. Suppose B already A is okay. A also you can write same variable, that is local variable there. Here local variable one more. Now you can initialize like this. Now this array you can pass A. Otherwise you can pass here new integer array operator like this. It is also valid, but only this type not valid. It's an error. It is not valid. Otherwise, better to go for initialization first. Integer, some array operator A. Okay. Otherwise, here already A is there. Here B is there. Otherwise, C. Okay. Now here you can initialize array. Here you can pass. Now you can pass C. After that, system dot out dot println x. Now this is, I'll explain with a diagram. Listen with concentration. Listen with concentration. See here what will happen, just observe. Here first of all, demo class loaded, open brace executed, main method called, open brace executed. Okay. Say first of all, demo class loaded, open brace executed, main method called, open brace executed. Now right side array created. How many elements? 5 elements. Right side array created. Now 4, 2, 6, 7, 8. Array index starts from 0. 0, 1, 2, 3, 4. Array itself object. Okay, this array object. Integer array object. This object referred by C. This object referred by C. Okay. Like this one array created. But with this object reference, we cannot call the method because this method is a member of demo class. Demo class object required to call. That's what demo object I created. Demo object I created, demo class reference I created. With that reference I'm calling. Then what will happen? This C copied in A. Okay. This C copied in A. What C contains? What C contains? Hash code. That is copied in A. That is copied in A. So whatever is there C here, that is copied. So it contains hash code. It contains hash code. That is only copied here. That is only copied. Hash code. This hash code refer this object means this hash code also refers same object. So Object is one. References are two. Person is one. Having two names. That type. Okay. Person is one. Having two names. Object is one. References two. That type. There is only one object. Array object. One more array not created. Many people what they'll think it is copied means all array elements also copied they'll think. Array elements are not copied. Only hash code copied. If array elements copied, then what's the difference between primitive and reference? Wasted. So even array can have 1,000 elements also. What is copied? Hash code only copied. 1,000 elements memory can save. Like so if it is primitive, all copied. It is reference. So hash code copied. Now after this, total equal to 0. So total equal to 0. Now int b colon a. From this array, one element copied in b. First one element copied in b. What is copied? 4. Now total equal to total plus b. 0 plus 4. It will become 4. It will become 4. Again, second element copied in b. These two copied in b. These two copied in b. 4 plus 2. It will become 6. Again, third element copied in b. It is 6. Already 6 is there. 6 plus 6. It will become 12. Okay. Again, next element copied. 7. 12 plus 7. 19. 19. 19. Again, 8 copied in b. 8 copied in b. 19 plus 8. 27. Now, this for loop terminated. Return total. This total copied in x. This total copied in x. Okay. Then here x. This 27. This 27 copied here. 27. This output printed. Okay. This is a reference type. Note on this one. One more time. Okay, I'll explain. Note down. Even array can have 1,000 elements also. Only hash code copied. Is it over? One more time I'll explain. Listen, not over. Say demo class loaded, open brace executed, main method called, open brace executed, right side array created with 5 elements. Array index starts with 0, ends with size -1, 5 -1, 4. Like this. That array referred by C. That means this object hash code stored in C. Array itself object. This object address mapped into another code, that code implemented with hashing technique that we are calling hash code, that is stored in C. This is over. Here demo object created. Why this object is? For calling this method. Because add elements method is a member of demo class. For calling this method, demo class object required. Demo class object created, that object referred by D. With that add elements method called. Then C copied in A. So this hash code copied here. This hash code refer this object. This hash code also refer same object. So object is 1, 2 references. Now total equal to 0. From this A, first element copied in B, that is 4. Total equal to total plus B. 0 plus 4, 4. Again second element copied in B, 2. 4 plus 2, 6. Again third element copied in B, 6. 6 plus 6, 12. Fourth element copied in B, 7. 7 plus 12, 19. Fifth element copied in B, 8. 8 plus 19, 27. After that, for loop terminated. Then return total. This total copied in X. System.out.println X. The 27 printed. Okay. Whenever you call this method, whatever with return keyword is there, no, that is comes and stored in X. Because this function method calling we are assigning to this variable. That's what whatever is this method returning, that is stored in X. Okay. Say before this variable, what we are doing, method calling. The method called, result copied in X. Like this relation. Okay. With return keyword, whatever you return, that is stored in X. This method called, result return, stored in X. This is reference type. What's the difference between primitive type, reference type? Data, hash code. Here hash code copied. In previous programs, data copied. That is the only difference. Is it clear? Tomorrow we'll see continuation. Okay. Tomorrow we'll see continuation.